Good evening, everybody. Today we will discuss the benzofuran, which is an most important heterocyclic compound in organic chemistry. So benzofuran, the name indicate that benzofuran, that means if 6-membered ring benzene is fused with a 5-membered ring furan. So we will get a benzofuran as the heterocyclic compound. And the benzofuran is sometimes it is called as coumaron, and it is isolated from the coal tar. Since the benzene ring is attached to the furan ring, it shows the aromaticity. That means the total number of the pi electron in the benzofuran is 10. So according to the Huckel's rule, 4n plus 2 is equal to 10. So n is an integer. That's why the benzofuran obey the aromaticity and it undergo the resonance structure. These are the resonance structure of the benzofuran. Next we are moving into the synthesis of the benzofuran. First method for the synthesis of benzofuran is we are treating our starting material is an salsilaldehyde, and the salsilaldehyde is treated with an chloroacetic acid and sodium hydroxide. So here the alkylation of the hydroxyl group will occur and we will get this compound. This is the product during the alkylation of the salsilaldehyde. And since we are using the sodium hydroxide, we will get the salt. And after that we are treating with the HCl. So the sodium is replaced by the hydrogen. And the resulting product is treated with an acetic acid and acetic anhydride. So we will get the benzofuran by the decarbonylation and dehydration. Now we are moving into the next method for the preparation of or the synthesis of the benzofuran. That is our starting material is coumarin, and the coumarin is treated with an sodium hydroxide, and this reaction is an example for the Perkins rearrangement. And here we can see that the hydroxyl group is attacked in the carbonyl group, and the resulting product, the cyclization will occurs, and finally we will get an carboxylic acid substituted or derivative of the benzofuran is obtained. And the next method for the synthesis of the benzofuran is the treatment of the vinyl furans with various dienophile, and this is an example for the Diels-Alder reaction, in which our diene is an substituted furan and the dienophile is an electron deficient species, and during the Diels-Alder reaction we will get the substituted benzofuran. Next method is the cyclization of the alkyne ortho substituted phenol. So here our starting material is treated with platinum PtCl2 in presence of toluene, and the temperature is 80 degrees Celsius. So we will get the substituted alkyl substituted benzofuran. Next we are discussing the chemical reactions of the benzofuran. The important chemical reaction of the benzofuran is the electrophilic substitution reactions. So consider our electrophile as NO2 plus, and the electrophile attack the benzofuran. We know that the benzofuran having an aromatic system, and electrophile always attack an electron rich part of the material or target molecule. So here in our case benzofuran, the NO2 plus attack the pi electron of an furan ring of the benzofuran, and the attack may be in the second or the third position. If the electrophile NO2 plus attack on the second position, there may be generated a carbocation which is in the third position. So the carbocation is highly stable, whereas if the electrophile attack in the third position, a carbocation is generated in the second position and it is highly unstable. So that's why electrophile always attack in the second position of the benzofuran ring. Next, we are moving into the other reactions of the benzofuran. The nitration can be occurs in the presence of N2O5, N2O4 and benzene. And similarly, the aldehyde substitution occurs by the treatment of POCl3 and DMF. POCl3 is always used for the the alkene formation. And the next method is the treatment of the benzofuran with a halogen. So the halogen is added in the double bond of the benzofuran, and usually the addition occurs in the furan ring. After that, the HX is eliminated. So we will get an halogen substituted benzofuran will occurs. The next method is the acylation of the benzofuran. Usually the acylation occurs in second position. The reagent used in the anhydride and tin chloride. Next reaction is the reduction of the benzofuran. In the reduction of the benzofuran, the hydrogen is used as a reagent in the presence of the catalyst as a PD. So what will happen? The pi electrons in the benzofuran, that is in the furan ring, is added by the hydrogen. So we will get a Kaumaran as the final product. The next method is the addition reaction by using the halogen. So the halogen is added in the pi electrons of the furan ring. So similarly, acylation can be done by using CH3CO twice O and BF3, which is the Lewis acid. BF3. So these are the reactions of the benzofuran. Thank you.